Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. We're in bonus weeks. We're in week number 66, and we are going to talk about the Go programming language, also called golang. We will talk about the difference between the way that Python is actually behind the scenes compiled into bytecode and then run, how Java is explicitly compiled, but that also goes into bytecode and then is run. And then we'll look at what we're looking at today, which is Go, which inherits from the way that C and C++ are done, in which case it's explicitly compiled, but compiled directly into machine code and run on the system that is the target system. So we will talk about Go. We'll look at some Go code and compare it to device Java, which we did most recently in the previous weeks. And we'll look at the Python version, which we also implemented, but quite a while ago. That was the first thing that we did. We'll look at a couple of different ways to do that device, one being a structure, one being a map. So we will look at that code. We'll look at the output for that code and understand what it does and how it does it. So that's what we'll be talking about. Hopefully this will be exciting. Let's get started. Okay, so let's get started talking about the Go programming language. Now, I have written a device Go program similar to the one that I did in the previous week in Java and the one that we did in our very first lesson, the very first code really that we did in Python, and I will be comparing those. We'll look at the output and we'll talk about that. But before I get into that, I want to give you a little bit of coding background and theory so you have a little bit deeper and broader knowledge maybe of software programming, how it all works, etc. And the thing that brought this up in my mind was people asking the question, is Python an interpreted or a compiled language? And I read an article where somebody answered yes to both, and it was actually a good article. And so I thought I would draw a little picture. I couldn't find one online that kind of describes how these things worked. And now we've talked about Python. Let me make this a little bit bigger for you. We've talked about Python. We've talked about Java, and now we're talking about Go. As you can see, I'm lumping together C, C++, and Go. That's because Go is kind of a ancestor. Its DNA is built on the way that C and C++ work rather than the way that Java or Python work. So people say, is it interpreted? Is it compiled? What's the difference? How does it run, etc.? So I just want you to have a little bit of understanding of how things work. Now Python, we call it, in fact, on the Python code description by the guy that invented it, he calls it an interpreted language. And what we mean when we say interpreted, typically, this is one definition anyway, is that I can say Python 3 and then I can go ahead and do some Python code and print things out. And it behaves as if it's interpreting the line by line as I type it in. And that's in general how it works. Contrast that to the way that things work in traditional programming languages like with C or Java, where you generally had to do a compilation step, and then after you were done with that, you could begin to run it. And so let's take a little bit of a look at that. Now, I've mentioned this in the class, but I didn't belabor the point, but probably now is a good time to bring it up. Python is actually compiled. You don't see the compilation step. When I came in here and ran Python, and then I said I equals 1, and then it executes that, and I just do I, and it prints the value of 1 there. We don't see a compilation step going on there, but in actuality, there is a compilation step that is going on. In fact, if you've seen files that have the suffix of .pyc in your folder, then you will know that, or you will assume that that is the compiled Python code, and you'd be correct if that's what you assumed. That actually has been compiled, and it's been compiled into what we call bytecode. Now, bytecode became very common in terms of the being used as a term and people becoming familiar with it with Java. And the idea of Java is that you would compile it into bytecode. You see down here at the bottom, in general, what compilers generally did was you had a C compiler and you would run the compiler and it would generate machine code. Now, as you can imagine, you would have different compilers depending on whether you were running on a Windows PC or on a Mac or on a mini computer or on an IBM mainframe versus a CDC mainframe versus whatever. The compiler had to be built special purpose for the destination where the code was going to run. With the advent of Java, we came up with this idea of bytecode, and the idea of bytecode is that things get compiled into a pseudo machine code language, but it is universal. And when you actually want to run it, then you're running inside this virtual machine that does the translation into the machine code depending on what type of machine you were running on. And the idea was write once, run anywhere. And our joke, who are Java developers, would always be write once, debug everywhere, because quite often there would be problems with it on a particular machine. But be that as it may, and all joking aside, it was a very noble goal, this idea that you would write your Java code, it would get compiled into bytecode, and then it would be able to run on Linux or Windows or Mac or wherever you were intending to have it run. Python is actually the same way. We say that it's interpreted, but in fact it gets compiled into bytecode, and when your Python code is running, even when it's running in a shell like this, it's running in a sort of a programming definition of a virtual machine. Now, it's not a VM like you run with VMware or with VirtualBox. It's a much smaller thing that just provides an environment for running applications in it. And it does this translation from bytecode into machine code and gives you the opportunity to actually write your code and not worry about whether it's going to be running on my Windows laptop or on my Linux machine. I can do that both, and people run it also on their Macs as well. So this is just a general idea, and so what we're going to be doing here, we're going to be talking about Go in this situation, and you probably want to have aware in the back of your minds anyway that this is what Go is. It's a compiled language, and it gets compiled into machine code, which is going to be appropriate for the destination machine on which you are running. So that's kind of the overview of how code goes from the nice stuff that you do up here into what actually gets run on the machine. Now, the first thing you need to do with respect to Go, if you want to play around with it, is you're going to have to install it. And if you go to golang.org, there is information about downloading it. I'm running this on Linux, so it gives me my instructions for how to do it. And they're not super trivial, but you can definitely figure it out if you've done some of this other stuff that we've been doing with Quokka and with 52 Weeks of Python. So that is where you will go. There's instructions for Linux, there's instructions for Mac, and there's instructions for Windows as well. So they're actually easier on Mac and Windows than it is on Linux. And then you'll want to be developing your code somehow, somewhere. And so I looked around for Go IDEs, and what I ended up choosing was Visual Studio Code. Golang is not free. When you plug it into IntelliJ IDEA, you need Ultimate, or you need to have it as a standalone IDE. I could not find a free version. I did do a fair amount of Googling to figure that out, and I was unable to see if I could find one. So I ended up using Visual Studio Code, which is what you see here. Now, I'm a novice when it comes to Visual Studio Code. I will let you know that I did run into some issues related to Visual Studio Code that have to do most likely with my own ignorance and nothing to do with deficiencies in Visual Studio Code but more with me, and I'll mention those as we go through. Now that you know in general how to install it and that you'll need an IDE, let's talk a little bit about the code. So here we are in Visual Studio Code, and I wanted to give you an overview of what we're going to talk about in this lesson on Go. Now what you see over here is our L01 device.py. That's the Python code that I wrote, that if you've gone through this course, then you've been through this creating a dictionary with all of these fields in it, and then printing it out and actually having a loop that goes through and prints it out in a kind of nice manner. We talked about Java in the last couple of weeks, and so I created a Java program that did the same thing. That's very simple. It's like my own hello world, but it kind of does more than just print out hello world. It creates a data structure, and then it does some looping and prints things out nicely. And so we looked at that. That's the Java version. So I did the same thing for Go, and you'll first look at this and say, whoa, look at all the code that was required for Go. Actually, that's not true. I did two different things. I did extra stuff in this code that we will be looking at. If you want to compare apples to apples here, then you'd probably be comparing basically this right here to those two, and you can see that they're fairly similar in terms of the amount of code that's going on. But I am going to point out some other stuff that really is more hereditary from the way that we did things in C in the earlier days in C++. So we're going to look at that a little bit in this lesson as well. So this is just an overview of what we'll be looking at. All right, let's look at the code. Now, as you can see, the code is in this file called device.go. You can see it's located in Python 52 weeks M17 Go. If you're pulling down the repository, you should be able to get this code. And so that is where it is located. This is what the code looks like. When I run the code, this is what it prints out. And looking at this, you can see what I've done is I've implemented device as a structure, and then I've implemented device as a map. That's why this code is longer than the Java and the Python version, is because I've done two different versions of this device implementation just to demonstrate the way that things go in the language Go or C or C++, versus the more common way that we're used to in Python and what I just did in Java, which is using some type of a map, which the official term for that is an associative array. It just basically means a collection of key value pairs, just like we've done before. So let's take a look at the code and see what it looks like. Here is my code in general, and let's go down to the bottom to see the main function. This is what gets executed when you run the program by saying what you see right here, go run device.go. There's a number of commands that you can give with the go command, subcommands that you can give, and run is one that will do the compilation step, and then we'll run it as well. So that is one thing that you need to be aware of, is it is actually doing a compile and then a run, and then it actually runs the code. The second thing to be aware of is in Visual Studio Code, you can configure this, but I have it set so that I need to explicitly do a Control S or go up here and do File, Save when I make changes. So if you're like me, then you will regularly make changes and then go down here and run it, and it won't be any different, and you'll wonder why. And if you look up here, you will be able to see that, oh, something has changed. Like if I just add a couple of spaces here, you can see that up there has gone to have this one file has changed, and I would do a Control S to save that. And you'll also notice, what did it do? It formatted it for me. So when it saved it, it did that formatting for me. So back at talking about the code, this is the main function. It's every example I've seen calls the main function main, so I'm assuming that that's a requirement, though I'm not 100% sure. But that does get executed when I run my program like I did over here. And I said go run device.go. It ran this code. And as you can see in my code, I'm actually calling two different functions. First, I call dev as struct. That's going to define a device as a structure and then print it out. And here's the output that you can see, device as structure. And then the second thing that it's going to do is device as map. And as you can see over here, I print out device as map. And then within that function, I also print it out nicely. That gives me an opportunity to use a for loop within Go. And so that is what my code does. Now let's take a look at these two functions. Actually, we can just pause right here. You can see the way that you define a function is going to be different in Go than it is in Python, which is different than it is in Java as well. So the keyword that we use to define a function is not def, which is how you define a function in Python, but it's func, which is how you define a function in Go. Another thing to notice here is that our code is not in a class. If you recall the Java code, everything was inside of a class and everything was an object that got instantiated and then we called here. This is a little bit more like Python where you just actually write the mainline code, except that it's in this function here, but you do just execute the code as is. You don't have to create a class and then instantiate an object. So I'm calling device as structure and device as map. Let's take a look at what device as structure looks like and does. Okay, so let's look at this device or dev as struct function and see what it does. In order for us to understand what this does, we need to little peek right up here because you can see I'm actually going to be using Devicestruct inside this function. So let's look and see what this is. When you see something that looks like this, it says I'm defining a type. So this is going to be like a template or the format of a piece of data that I can then define. So I'm defining my own data types here. And my data type is a structure and it is going to have these fields in them: name, vendor, model, OS, version, and IP. You can see the type of data for each one is going to be a string. When I define something like this, it allows me then to declare a variable that is of this type, and then I can refer to the name field as whatever my variable is, .name or .vendor or .model. And so it makes it very handy. It makes the code very readable. It makes it very structured and statically defined in the sense that these are my fields and we're going to adhere to this kind of contractual definition of what a device is going to have in it. And so when I then use it, as you can see, I'm using it down here. I want to print out the name. Then you can see I can use this dot notation where I say dev.name. Dev is the device structure that I created. I say dev.name and that will print out the name. And as you see right here, I've printed out the actual name of the device that I've created. So this is like a type definition for a type of data that I'm then going to define. Now let's look at where I declare and define the data for this variable. Now sometimes in Go, what you will see is the use of just an equal sign, as you see down here. And when we get into a little bit more robust code, like my host monitor code that I'm in the process of doing, that I've done some of, we will have more examples of this. But for right now, let's use this as an example. Here you see an equal sign, and yet here, and then up above here where we're looking at it, you see this colon equals. What does this colon equal mean? Well, a colon equal serves to tell Go that I am both declaring this variable name as well as assigning some value to it. And what is the value I'm assigning to it? The way that they've done the Go syntax is that I put the name of the device type, which is, of the data type, which I've defined up here as my type def structure. I put the name of the device type right here, and then I use curly brackets. Now, don't be confusing curly brackets in the world of Python or even in the world of Java. People use curly brackets and special characters for different things. You just have to learn when you're in a language to use what is defined appropriately for that language. And when I want to create a piece of data with values, as you see right here, I'm setting the name and vendor and model to these particular values. When I am doing that, I use curly braces. So as you can imagine from looking at this, I'm creating a variable called dev. It is going to be a device structure, which means it will have .name, .vendor, .model, etc. And this is how I initialize all of those values by saying name colon value. This should look similar to Python. This is a little bit how we define fields that have a key and a value in a dictionary, let's say, but this is a structure, so it's statically defined, and I can't go adding fields to it. It needs to stay exactly like this. So this is my structure, and I can then print it out, and it prints it out, as you can see here in this code. It's printed my device out. This is how Go prints it out. You can see it in this situation. It's just printing out the values. It's not actually printing the name of the field. So it's just printing out the data. That is what, let me squeeze this down so you can see both. That is what this right here, device colon, and when I print out device, it's assuming that you will know the names of these fields. It's not really intending to be a very nice printing of this data. But if you want to reference them specifically, then you can do this next line, device name, and there I do dev.name, and here you can see that I have printed out the device name. Now there's probably ways to get this to print out the field as well as the value for that field, but this is all that I've done in our short lesson here, because I want to go on to something that is more similar to what we've done in both Java and in Python, which is using a map, which is the similar thing to what Python calls a dictionary. So we'll look at that next. Okay, let's compare how we declare our map in Go versus how we declare our hash map in Java versus how we declare our dictionary in Python. Now I've modified this from the version that is out there right now just so that I can show the similarities between Python and Go in this situation. So the way that I declare my map is using the make keyword. Notice that I'm using this thing that indicates that I'm both declaring and assigning my variable. So I'm doing a make, and what I'm doing right here is I'm saying this is going to be a map. The key is going to be of type string, and the value is going to be of type string. That's just how they've defined things to work in the Go programming language. How we do it in Java, if you recall, I declared a hash map with these angle brackets that say that the type is going to have string as a key and string as a value, and its name is going to be device, and then I need to say new because it's going to be a new object that I create. On the other hand, what we did before in Python was I did this code, which is how I initialized my dictionary. If I wanted to do it similar to the way that we do in Go, I would just say dict. Over here in Go, I had to specify the actual data types for my key and my value. I don't have to do that here. And then I just proceed to go through. You will be happy, or maybe not, or interested to know I copied this code right here exactly from this code right here. So this is one of the situations where the actual code, the syntax of the code in these two situations is actually identical. So that is how we declare things and we set these values. Now, the one thing that I want to point out that we didn't go over is how do I set the values in Java? Well, in Java, we need to use the actual name of the object, which is device that I created. And then if I want to set values there, I need to do put. And if I want to get values, I need to do a get. And in our situation, we of course don't have to do that. We just reference it using the name of the variable followed by, in square brackets, the key. And that is the same way that we did it in Python. So that may look familiar to you. So that is the definition of the data, the actual variable that we're going to be using, and we're specifying the actual data type. I know that this is a little bit confusing to look at. You will not be comforted to know that when we actually do things, like in my host monitor implementation, this gets a little bit more confusing as well. But hopefully you can hang with that. This is a map, and the map, the syntax for declaring it is this stuff that I've highlighted. The key goes in the square brackets, which kind of makes sense because that's what you see down here. And then the value, the data type of the value is going to be out there. And this is how I set it. And here I'm printing it. It will print my entire device name in this situation, as well as being able to just dereference one of these. And before I go to this for statement, let me go and get rid of this stuff that we use for comparison. Let me make this smaller so that I can get at this. And this is what this looks like. So these lines right here, this device and device name, when I print device, you'll notice, remember when I printed a structure, this is what it printed out for me. When I print out my map, what it's going to do is it's going to tell me that it's a map. Then it's going to put square brackets, and it's going to use this common notation that we see where I have the key, in this situation IP, and the value on the right, and it's going to separate them by blanks. Here I have model, and this is the actual model. So you see blanks can be a little bit confusing in this situation. They're not definitive in this, just be aware of that. My name is this name right here. My OS is this value here. My vendor is Cisco, and my version is this value right here, which is what we set up there. And when I want to dereference or refer to just one specific item, I use the notation that we're familiar with in Python, where I use square brackets and I put the key inside those square brackets. And when I do that and it prints it out, sure enough, there is my device name. All right, next we will look at device as a map, nicely formatted, and we'll learn some new stuff about Go. Okay, so the last thing that we're going to look at is this for loop right here. Now, before I go into that, you may be wondering where can I get more information about Go. Let me tell you about this nice website that I found. It's called Go by Example, and if you just type in gobyexample.com, you'll end up here, and this will show you simple pieces of code with descriptions alongside every line of code that describes exactly what it is doing in every situation. So it starts out with hello world. If you're interested in for, this is a bunch of for statements. I'm actually going to be using a for statement with a range, and so this will define, okay, this is what a range is. It iterates over elements in a variety of data structures. So this is a good spot to go to if you're interested in Go by Example. I will warn you, it starts out very simple and then it gets into fairly deep-ish programming, software development topics, so you can just ignore those and only look or cherry pick the ones that you want. But let's look at our for loop and see what this does. I think you'll be able to get the general idea. This is a for statement, so we're doing some type of a loop, and of course this is the brackets that are going to define the data in the loop, and we're going to be printing something out. So what are we looping across? Well, we're going through this thing that we've defined called range. And so, sorry, this thing that we've created called device. And so device is, as you know, it's a map that we've defined with all of these different items in the map. And the way that you iterate, as I just mentioned by looking at Go by example, the way that we iterate over data structures is we use this range keyword. And so if this was just a list or an array of some type, then it would just be giving us one value. Because it is a map, it's going to be giving us two values. So it's going to give us both the key and the value. Remember, in Python, we would need to say device.items, open and close parentheses. In this situation, Go is smart enough to know, hey, I know what type of data that is. It's a map, therefore I'm going to return two different things, the key and the value. And here's our friend colon equals. Remember, that's what we do when we're declaring it. And since the first time through anyway, we're declaring key and value, then we need to be using a colon and an equals. And what are we doing? We're doing a print. I haven't gone into detail about print statements, but you can see there's print line. There's also a regular print. In this situation, there's a print F. Print F is going to do printing of a formatted string. Now remember, F strings in Python are really handy. I haven't seen anything like F strings in Go, at least not yet, and not in the little time that I've had exposure to it. But this is the old school way that we would do things in the C programming language, and maybe you've done this in Python as well. Using the %, this says, okay, this is where a variable is going to go. And my formatting options here, 16S says, I want you to take up 16 characters for this, and I don't have any other instructions other than that. Then I'm going to be printing this exact thing right here, which is a space colon space. That's actual data. Don't worry about it's not any special syntax. It's just data that's going to get printed, characters that's going to get printed. And the next thing to get printed, I am going to be specifying that it with a % again, and then I'm doing a -s. The minus says I want you to left justify this thing. So the thing on the left hand side is going to be by default right justified. It's going to take up 16 characters. The thing after the colon is going to be left justified, and it's going to take up as many characters as we need. And when we look down here at the data, this is my nice output that I did in the Python situation. I just replicated that in the Go world. And so this is what that data looks like. So this for loop is going to go through until it's done, and then we're going to return. And that is this device application using Go. And remember the things that we talked about. We both did this structure, which is a different thing. It's kind of new for those of you that are new to software development. It's something that is common in C, C++, those types of languages with static type declarations. And we use that here. And then we did stuff that we're more familiar with. The thing about this is that you can always add new fields if you want to, kind of on the fly. It's not a big deal, but this provides better type checking as when you compile it and make sure that you're doing things appropriately. So that is our device in Go. Okay, let's review what we talked about in this lesson. We're talking about programming in Go, and we talked about the difference between languages that got compiled and languages that are interpreted. We looked at Python and how it is compiled behind the scenes into bytecode and then translated within the virtual machine into machine code. We talked about how Java is explicitly compiled, and then that bytecode gets run also in a virtual machine, the Java virtual machine. And we talked about how Go, just like C and C++, which are its ancestors, is compiled explicitly directly into machine code that runs on the machine. We looked at differences in our device code. This over here is the initial thing that we did in Python. We looked at how we did it in Java, and we looked at how we did it in Go, and we mentioned that it's a lot more code because we did a couple of different things. In Go, we looked at defining structures, which is something that you do in C quite a lot, and C++ as well. So we have a version where we do the basic functionality that we do over here, but we do it with a structure, and then we do it with what's called a map. A map is like a hash map in Java, which is basically a dictionary. And so we looked at storing this information. We looked at the output and what the output looks like. And yeah, that's kind of what we did with our Go code. We did look at aspects of the Go language. We looked at defining structures and how you reference them using dot notation. We talked about how maps you utilize once you've defined them. You use them in a very similar way to how you do it with Python dictionaries. We talked about the difference between a colon equals, which is where you declare and assign the variable, and just equals, where you're just assigning the variable. And lastly, we looked at the for loop, which is how you do looping in Go. We talked about how you can use range to iterate through data structures such as a map. So in this situation, we're getting the key and value and iterating through it. And lastly, we looked at the print statement, which is not as smooth as what you get with Python over here, but it is the way that it has been done in C and also in Java for printing stuff out. So there you go. That is kind of Go in a nutshell. We just did this thing. Next, we will look at an actual application that's doing host monitoring, getting information from HTTP from our Quokka Prime server, and then doing some monitoring. But that's next time. As always, hopefully this has been useful to you. And if you have any questions, let me know. Thanks for watching and listening.